Okay, so we have saturated all of our pots and we have numbers for you to fill in your chart. So the saturation volume for sand was 133 milliliters, for peat was 325 milliliters, for the peat sand mix was 203, and for the forestry mix was 250. And even though they're all saturated, they do look a little bit different, but we have, you know, all of the pore spaces filled with water, and we have a thin film on top of the sand for sure and the sand peat mix. So now what we need to determine is how much water is going to drain out of this saturated media, and that will be the next thing that we can fill in on our chart to determine the things we need to determine. So we can expect that some water that we put in is going to stay in the containers because it's now adsorbed or stuck to the outside of our particles. So the way to drain them, we're going to very carefully hold our pots over an empty vessel, and we're going to try not to squeeze them and not to tip them because we just want the gravitational water to fall out. So we're going to very carefully remove our high-tech pot plugs of plasticine and let the water drain out of there freely. And this may take a few minutes to get everything off of there and let it drain. You can do that, should have done that before we started recording, but that's all right, you're along for the ride now. Okay, and once the plasticine is off, then we're just going to place the pots of media in the pots to collect the water and let everything drain. Most of what's going to comes out fairly quickly, but there could be some that comes out over time. So we'll just allow some time for that to happen. Okay. You can hear random drips leaching through and coming out of the peat and the sand containers still. So there will be some that filters out as time goes on. Ooh, that was a piece. It's like peeling skin after a sunburn, which is terrible advice. You shouldn't do that. Alrighty, so now that we've got our gravitational water, we can take our pots of medium out. Just make sure that you didn't miss any holes like you did here. There's some more. All right. Now to measure what's left in here, we want a really accurate measurement, and we can't get that in these beakers. So we're actually going to pour from there into our graduated cylinders, and that will allow us to measure a little bit more accurately. So we're starting with peat, which is the second, actually let's start with sand and keep it consistent with how it appears on your lab sheet. So for sand, we can see that not a lot of water came out, but we still want to measure it more accurately. in the graduated cylinder. So for our sand, we put 133 milliliters in and 12 came out. So our gravitational water for sand is 12 milliliters. Now we'll move on to the peat, so we're in the right order for your worksheet. This is going to fill up a few cylinders. And we have some solids in there, but that's okay, they float to the top, so we can get a fairly accurate reading with those on there. All right, so for peat, we had 325 milliliters go in. We have 50, 100, 150, and 157. So our gravitational water for peat is 157 milliliters. We'll do the peat sand mix next. And same deal, we want to measure with the graduated cylinder for more accuracy. So for peat sand, we had 233 milliliters for our saturation volume, and our gravitational water is 31 milliliters. And lastly, our forestry mix. So forestry mix, we had 250 mils go in. And this one likely will need a couple graduated cylinders as well. Okay, gravitational water for the forestry mix is 145 milliliters. So you can take those numbers, fill in your part of your chart, then plug them into the calculations to fill out the rest of your chart and answer the questions.